So now let's look at some trigonometric substitution problems. So this is number 3, trigonometric substitutions, what we normally call trig subs. Um, so we know there are three type of problems. So one is when we have a squared minus x squared type of expression. So any power. So I'm going to put a box there. So we gonna use x equal a sine theta. So remember the order is a squared minus x squared, and then we know that the derivative gonna take the form a cosine theta d theta, and then we have a squared plus x squared to some power, positive, negative, half, anything you like. So x equal a tan theta. That's the next type. In this case, we have dx equal a secant square theta d theta, and then we have x squared minus a squared. So that's the first one, reverse the order, reverse order. The substitution is x equal a secant theta. Why we do that? And you can see that if you use this kind of substitution, you can simplify inside. So that's the goal, you can simplify inside. And then this is going to be dx. So if you take the derivative of secant is a secant theta tan theta d theta. So let's try to do three problems of each type just to remember what we did. So let's start with this problem. And also in these three, actually I want to tell you all those the identity that we can use. So identities. So we can use identities. In the first one, we can use sine square theta equal 1 minus cosine square theta. Oh, cosine square theta equal 1 minus sine square theta, depending on the integral. So you can use both. And then we can also, for the second one, this is the tangent substitution. So once you substitute tangent, you're gonna use secant square theta equal 1 plus tan square theta, or you can say tan square theta. So now that's also useful. Tan square theta equal secant square theta minus 1. So those are the identities that we can use in this section. Sometimes you also have to use the double angle formula. So I'm going to recall those two also. So we have to use sine 2 theta equal to sine theta cosine theta, and also sometimes we can use these cosine square theta equal 1 plus cosine 2 theta over 2, and sine square theta equal 1 minus cosine 2 theta over 2. So those are the kind of identities that we can use in this section. So you can see we can use most of them, if not all. So let's look at some problems, like three problems of each type. So we can start with this one. So let's say we can integrate. So the problem is integrate this one. Let's start with 9. Actually, I'm going to start here. So let's say integrate 9. I need space. So 9 minus x squared square root divided by x squared dx. So that's the kind of problem. And you can see that you don't see any obvious method other than these trig subs. So we're going to go with the trig sub in this case. So a equal 3, because 9 means 3 squared. So you can say x equal 3, that's a 3 sine theta. That's what it says, because the a squared minus x squared format. And then if you take the derivative, this is going to be 3 cosine theta d theta. So let's substitute that. So if you substitute that, you can see this is going to be 9 minus 9 sine square theta square root. In the bottom, you're going to say x squared. So that means 9 sine square theta. And then we have dx. Dx equal 3 cosine theta d theta. And then you can see this simplifies very well. We have 9 as a common factor. Under square root, it becomes 3. So you're going to get 3. And then we have uh, another 3 up there, and in the 3 in the bottom. So you can see all those 3 get cancelled. So actually I can write it here just to show you what's going on, but you can see they cancel each other. Okay, those are the 3 terms that you get. And then we have 1 minus sine square theta square root. That's what you have. In the bottom you're going to see sine square theta, and we have cosine theta d theta. Some steps are not really necessary, but I'm writing it for completeness. And then you can see 3, 3, 9, all those get cancelled. And then 1 minus sine squared. 1 minus sine squared means cosine squared. So I'm also writing this step. So that means you have cosine squared theta square root. In the denominator you have sine theta, sine squared theta, and we have cosine theta d theta. And you can see cosine square theta square root, we assume that in the domain is positive. We take the domain where the cosine is positive. So you get, so square is the cosine and cosine, so you get cosine squared. So that means you can write this one as cosine squared theta over sine squared theta d theta, which is simply cotangent square theta d theta. Now the question is how to integrate. There's no direct formula for that, but if you write it like this, if you write it this one as cosecant square theta minus 1, now you can see you can integrate this one, because integral is simply the cosine squared. That means it is negative cotangent theta minus 1 means theta plus c. So that's what you get. Now what you want to do is to find the cotangent. So in one way you're done with the integral, but in a different domain in theta. What you have to do, you have to convert that into x. So what we can do, we can use the relation. So we can write this one as, you can see sine theta is equals to x over 3. With this gonna give it theta is sine inverse. So it says that theta is sine inverse x over 3 if you take inverse of both sides. Now also we can draw the triangle using the same identity. So if you draw the triangle, what's happened is this is sine, that means x over 3. So this side is 9 minus x squared. Now since we have all the sides, we can find anything you want. According to this one, cotangent theta is adjacent over opposite. So that's what you get for the cotangent. So it's been negative 9 minus x squared square root over x minus theta, which is sine inverse x over 3 plus c. So that's the answer for the problem. You can see it's not long, but still we need to remember certain things. Okay, so that's the first example. Now let's do another one using the other substitution. This was sine. So look at the format. It is a squared minus x squared format, and the substitution is sine. So let's do another one that use a different substitution. So how about this problem? So example number 2. Let's look at this one. So let's say we have dx over 4 plus 9x squared to the squared power. So if you see something like that, we don't see any direct method other than the trig sub for this problem also. But what we can do is we can do some small arrangements. For example, you can write this one as 2 squared plus 3x whole thing squared square root. Then you're going to see what are the terms that you're going to substitute. You can see this is a tan substitution because of the plus sign. And what you can do here, you don't have x, you have 3x, but that's okay. So what are you going to do? You're going to say 3x. Instead of x, you say 3x equal a tan theta. A tan theta. Okay. Instead of x, now you have 3x. So that's okay. It doesn't matter. And then so we have everything we need. So this says that x is equals to 2/3 tan theta if you want to substitute for x. And then also we can take the derivative, so dx is equals to 2/3 secant squared theta d theta. Now as before we're gonna do the substitution. Okay, so so that's what we did here, and that's the derivative term. Okay, and then let's substitute. So if you substitute, what are you gonna get? Dx, which is 2/3 secant squared theta d theta, and in the bottom what we have is we have 2 squares of 4 plus 2x 3x equal 2, so you're gonna get 4 tan square theta, and then okay, this one is square root, so I think I by mistake put the square root here, so this has to be square. So okay, good. And then yeah, so that's what we have. So let's simplify this a little bit, and you can see so what kind of simplification we can do. So here, so we can pull out, so we have 4 and then we had 4 square, because you can take 4 as a factor here. See, you have to 4 as a factor, but you have a square. That means you can, it comes out as 16 in the denominator, and then with the 2 in the numerator, it's got 8. With 3, it's going to be 1/24. So you can write this as 1/24. 1/24. And then in the numerator we have secant square theta d theta, and then also here we have 1 plus tan square theta whole thing squared, and you can see so how to simplify this one. So 1/24, and this is secant square theta, but we know that tan square theta is secant square theta, so because of that denominator you're gonna get secant 4 theta d theta, 4 theta, okay, with 4 theta, and then we have d theta. Okay, now you can see you can simplify this a little bit. So this 2/24. So we have secant 4 secant squared over secant 4. That means you can cancel, you get secant squared. So this is 1/secant squared theta. That means it's a cosine. So it's a 1/24. It is simply cosine squared theta d theta. This is an even power, so we can use a double angle formula. So that means it is you get 1/24. So you have 1 plus cosine, you double it, so 2 theta over 2 d theta. This is very easy to integrate, term by term integration. So this is 1/48. If you integrate from the one, you get theta. From the other one, we have cosine 2 theta. Cosine means sine, but you have divide by whatever the number you have here. So that means you have divide by 2. That means 1/2 sine 2 theta from the formula. Okay, we know that if you have a constant, just divide by the constant, so cosine becomes sine. Now what you're going to do is you're going to substitute. So how you do, don't just substitute for theta, because we know that the theta you can substitute for theta is simply tan inverse 3x over 2. That is really not the right way to do it, because if you do that you still have to simplify this. So what do you normally do is we can use a double angle formula first to simplify this. So we can write it like this. So we can write this first like this. So 48. So theta is fine, we can substitute for that. Here we can write this one as using double angle formula. This is 2 sine theta cosine theta plus c. So we have to do that first, and then what we're going to do, we're going to substitute for sine and cosine. So so let's do this. That's the right way to do it. And then also you can see that this 2 and that 2 get cancelled. So let's try to find the sine using the triangle. So what we can do, we're going to draw the triangle using this identity, because this says that tan theta is simply 3x divided by 2. That means if you draw the triangle, so this is the theta, this is tan, so opposite over adjacent. So that means you're gonna get this one is 2 squared plus 3x squared square root. That's what you get. Now we can find the sine and cosine. So this says that the sine theta is simply 3x over 4 plus 9x squared square root, and then comma cosine theta is 2 over 4 plus 9x squared square root. So what you can do is we can substitute those two here. So once you do that, you're going to get 148. Theta is simply from the first, this one you can see theta is simply tan inverse or arctan, so tan inverse 3x over 2. You don't need the parentheses here because it's a fraction, and then plus we have sine theta, cosine theta. We're going to substitute for those two, and then once you substitute for those two and simplify, what you're going to get is, because you have square root that cancel out, so you simply end up getting 6x over 4 plus 9x squared plus c, because square root get cancel out. So that's the answer for the problem, and you can see just like basic simplification, but that's what we consider the final answer. And do not just substitute for theta in this line. Okay, so I know some people try to do that, but that's not fully simplified. I know, like, they try to substitute for theta as sine 2, and then for theta some people substitute as tan inverse 2x, tan inverse 3x over 2. That is not that's not the final answer, because that's still you have to simplify if you do it like that. So don't write it like that. That's not complete. Okay, let's do the one last problem that use the secant substitution. So this is the problem. So let's try something like this. So let's say we have x plus 1 over x squared minus, I just put some numbers, I just put 4. Okay, so dx, something like that. And you can see this is the third type, because x squared minus something, x squared minus, if x squared plus is a tan, it's x squared minus, so secant. So and then in this case a equal to, so we can use x equal to secant theta substitution. So dx is to secant theta tan theta d theta. So let's substitute and see what's going to happen. So x, which is 2 secant theta plus 1 over 4 secant square theta minus 4 square root, and then dx, which is 2 secant theta tan theta d theta. So let's simplify this. So it is 2 secant theta plus 1 divided by, and you can see 4 as a common factor, take out, under square root become 2. So you have secant square theta minus 1 square root, and then 2 secant theta tan theta d theta. And again, we know that secant square theta minus 1 is simply tan square theta, under square is become tan. I'm going to write this extra line, and also you can see that these two and one of the two, these two get cancelled, not the other two, because you should put a bracket here. I mean, you don't, because it's under fraction, but just for clarification I put a bracket there. Now what you get is 2 secant theta plus 1 divided by, because it's tan squared, under square root it's just tan, and we have secant theta tan theta d theta, and you can see tan get cancelled. So you get, what do you get? You have to multiply by secant, so you get 2 secant square theta plus secant theta. These both we know the formula. First one is secant squared, that means simply tan theta, Second one is natural log. Secant theta plus tan theta plus c. What are you going to do? We're going to substitute for tan and secant. So what do you do? As before, draw the triangle. So we can use that. So we says that x over 2 equal secant theta. That means 2 over x equal cosine theta if you want. But you can just use the first one to draw the triangle. But if it is difficult, just do it like that. And then this is a cosine, so it is 2x. And so this can be x squared minus 4 square root. Now we can find a secant and tan here. Secant already know, so according to this one, tan theta, which is x squared minus 4 square root over 2. So we can substitute for all of them. So it is 2 tan theta is x squared minus 4 square root over 2 plus ln secant, which is x over 2 tan, which is x squared minus 4 square root over 2 plus c. Okay, so some people, I mean, you can consider this as a final answer, but you can do some simplification, interesting ones. For example, the 2 get cancelled, that's one. The other thing is, you can see this is a common denominator. Since it's a common denominator, you can collect them, you can combine them, then you get 2 as a common denominator, but now it's a fraction. You can see in the top, you have x plus x squared minus 4 divided by 2. So that means you can write this as a log difference. Then you get a ln2. You can subtract ln2. That ln2 you can combine with this c as a constant. So finally you can write this answer as x squared minus 4 square root plus ln just x plus x squared minus 4 square root plus c. This c is different from all c, but you can as the final answer. This is much better, but these two c's are different because the second c has original c minus ln2, so this is simply c minus ln2. So that's, but you know, it's just a constant. So that's the final answer. So that's how you use those three trig subs in a problem.